Welcome to part 4 of this series. In this video, we will level up our skills by solving more challenging quadratic equations and also demonstrate how to analyze and solve application problems. Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Welcome to the fourth session of this quadratic equation topic. The first example here is a quadratic equation with an unknown constant m. The question is to find the value of this m given the criterion that the two roots of this quadratic equation satisfy the equation of the reciprocal of x1 plus the reciprocal of x2 plus 2/3 equals 0, which is called the auxiliary equation here for convenience. According to the Viada theorem, we have x1 plus x2 equals m minus 1, and x1 times x2 equals negative m. We start to manipulate the auxiliary equation, and then it becomes the sum of x1 and x2 over x1 x2 plus 2/3 equals 0. Since x1 plus x2 is m minus 1, x1 times x2 is negative m. Therefore, the equation turns to be negative 1 plus the reciprocal of m plus 2/3 equals 0. Hence, we find the value of m, which is equal to 3. Question 2 shows that alpha and beta are the two roots of the quadratic equation x squared plus 2x minus 7 equals 0. The question here is to find the value of the expression of alpha squared plus 3 beta squared plus 4 beta. Here we call this expression as the value expression for convenience. Of course, we can solve this quadratic equation and find the two roots and then substitute them into the value expression to obtain the result. However, as we have learned, using Viada theorem to simplify the value expression first is a better approach for this question. Now, according to the Viada theorem, alpha plus beta is equal to negative 2, while alpha times beta equals negative 7. Based on the above, we start to simplify the value expression by grouping and partially factorizing it, and then substituting the value of alpha plus beta into it, which is negative 2 here. Finally, we simplify the value expression to 4 times the sum of beta and 1 squared. After this step, we go back to the original quadratic equation and use the formula method to work out the two roots. As always, we calculate and check the discriminant of the quadratic equation first, and then apply the quadratic formula to calculate both roots, that are negative 1 plus 2 square root 2 or negative 1 minus 2 square root 2. Therefore, the value expression is equal to 32 or 48 plus 32 square root 2. It depends on the values of beta. Question 3 tells us alpha and beta are two distinctive real roots of the quadratic equation x squared plus px plus q equals 0, where either p or q is not 0. There are two questions follow. The first one is to prove p squared over q is equal to m plus n, or in parentheses squared over mn, given the criterion that alpha over beta equals m over n. The second question is to prove that q is less than 1, given the criterion that alpha squared plus alpha beta plus beta squared equals 3. We are going to use the theorem to solve both questions. As for the first one, since p equals the negative sum of alpha and beta, while q equals alpha times beta, so p squared over q is equal to alpha plus beta, or in parentheses squared, over alpha beta, which equals alpha over beta plus 2 plus beta over alpha, and it equals m over n plus 2 plus n over m, which equals m plus n, or in parentheses squared, over mn. Therefore, we have done the proof for question 1. As for question 2, we manipulate and simplify the left-hand side of the equation first, as we have learned the skill to transform the left-hand side of the equation to alpha plus beta, or in parentheses squared, minus alpha beta. So the equation becomes p squared minus q equals 3. Now we are going to use the result of question 1, as we have already proved. Substitute p squared by m plus n, or in parentheses squared, times q divided by mn. Then we have the equation with m, n, and q. Therefore, q can be expressed as 3mn over the sum of m squared, n squared, and mn. Since m squared plus n squared is greater than 2mn, therefore q is less than 3mn over the sum of 2mn and mn, which is equal to 1. Hence, we have proved that q is less than 1. Question 4 is an application of quadratic equation regarding rate, time, and volume. The first step is to establish the equation, and the next step is to solve the equation. Let's assume x is the number of days required for one apprentice to finish the job alone. Hence, the number of days required for one qualified painter to finish the job alone is x minus 15 days. Let's also assume the total workload for the job is w. Hence, the rate for one apprentice is expressed as w over x. Accordingly, the rate for one qualified painter is w over the result of x minus 15. So the total rate for 3 apprentices and the 2 qualified painters work together is 3w over x plus 2w over the result of x minus 15. After having the expression of the total rate, the equation can be established based on they work together to complete the job in 3 1/8 days. So the equation is w over the sum of 3w over x and 2w over the result of x minus 15 equals 3 1/8. As it can be seen from the equation, the workload simple w can be cancelled out. Here we continue work on question 4 from the last slide. As it can be seen, the left-hand side of the equation can be transformed to a single fraction x times x minus 15 over the result of 5x minus 45 equals 25 over 8. Cross-time the fractions on both sides of the equation, then simplify them to make it as the standard form of a quadratic equation. Finally, it shows 8x squared minus 245x plus 25 times 45 equals 0. Please note, we leave the constant term as 25 times 45 purposely because it is easy to break them into different factor pairs to test. Here we just show the combination of the correct factor pairs that match the linear term. After being factorized, the roots of the equation can be obtained. x1 equals 45 over 8 days, while x2 equals 25 days. Since 45 over 8 is less than 15, so the solution here is that it takes 25 days for one apprentice to finish the job alone. Question 5 is an application of quadratic equation regarding distance, speed, and time, which is the same type of problem like question 4. The first step is to establish the equation based on the given criteria. The second step is to solve the equation. Since x km per hour is the bus usual average speed, so the usual time required for the bus to travel 75 kilometers is 75 over x. After the speed being increased by 12.5 km per hour, the required time to travel is 75 over the sum of x and 12.5. Now we can compare the required time between the bus traveling at normal and at increased speed. According to the given information in the question, the difference is 18 minutes. Please note this 18 minutes has to be transferred to 18 over 60 hours. So the established equation is shown on the screen. 75 over x minus 75 over the sum of x and 12.5 equals 3 over 10. To solve this equation, we need to combine the two fractions on the left hand side of the equation. After being simplified, it becomes x times the sum of x and 12 over 2 equals 25 times 25 times 5. We continue question 5 here. After all the terms being moved to the left hand side of the equation, the form of the equation becomes a standard one: 2x squared plus 25x minus 25 times 25 times 10 equals 0. We purposely leave the constant term like this in order to easily break or combine factor pairs to match the linear term. Here, the correct factor pairs are shown on the screen that match the linear term 25x. So after the new factor law being applied, two roots are obtained. One is negative 25 over 2, the other is 50. Since there's no negative speed in this case, therefore the solution for the question is that the bus usual average speed is 50 km per hour. As for question B, after increasing 12.5 km per hour in speed, it takes the bus 75 over the sum of 50 and 12.5 hours, which is equivalent to 75 over 50 minus 3 over 10 hours, which is actually 1 hour and 12 minutes. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.